Well, thank you. First, I would like to say sorry because my subject is aromatic, but not like a coffee. This is so different. So, well, good afternoon. Today I'm going to talking about one of the line of research in our laboratory is the developing of analytical method using 3D printing for in-situ monitoring of pollutants in wastewater treatments. So in this case, we are focused in the waste treatment, but we can use 3D printing in other subjects. Okay. First, everybody here knows the potential has the wastewater flows. For example, for anaerobic digestion, we can have gas, for example, biogas, and however, we have as well a big source of pollution with a mixing of complex pollutants. So for this reason, analytical strategies are necessary to determine the presence of pollutant in wastewater and facilitate the decision on the sustainable management of the water cycle. So when we start to think about the analytical strategy, we have a problem, so we need to do what kind of step we need to follow. But we need to check as well the analytical traceability and many characteristics. But the problem is when we go into the real work, we find important and different steps for analysis. And the additional question, like, okay, my sample, my analyte is what chemical properties have, what sample volume I need, biological degradation can be possible, what concentration I have. And that is very important to know because if we have this, we had 16% the time we use to make the preparation and collected of sample. So for that, for this reason, the analytical change is the development of analytical tools that allow the extraction and determination of pollutant in fast and sensitive way. For that, miniaturized methodologies allow certain advantages as portability, in-situ extraction, or determination for the chemical substance. In this way, we have two possibilities. The first one is to make an extraction in situ after analysis in the laboratory. And the other one is to make extraction in situ as well, but analysis in situ in field. For that, that's allowed to have a decision in the moment. So the objective of this project is the development of miniaturized and portable analytical tools using 3D printing for in-situ monitoring. And for that, we use the 3D printed or additive manufacturing that is a process of making three-dimensional solid subject from a digital file. So we can see the different steps. We have first a model creation in software. Then we have the file transfer because we need to change. We can buy the device and finish. We need to processing this device. So for this kind of technology, we can two possibilities. For example, in situ device and in situ extraction device. The first one is analysis. Well, we can make an spectrophotometer, for example, or we can make device for extraction. For that, it's important as well to say we can use different technology, for example, advanced materials like MOF, other resins or MIPS, and digital technology like a smartphone or webcam. For that, now I will show you the different methodology that we are using for developing functionalized portable devices. Okay, the first step is design and manufacture 3D devices. For example, we can use a software like a Rhino0 3D for make the first design, and then we can make the solid or the impression of the device what we want. The next step is optimization of this kind of device, because here you have a device and the other one is the picture and the microscope, and the problem is some of the resin we use can be different properties or chemical or physical different stability, so we need to check that. Then, the next step, we need to select the extraction materials or advanced material to cover this device, okay? The next step, we have the first one is without MOF, for example. The second one there is with MOF, okay? We need to immobilize this selective material in the devices. So the last one step is test or make an evaluation about the extraction capacity. So we need to check the, for example, the dissolvent, the pH, and the different cycles we can use the kind of device. Well, now I would like to show you different development of analytical sampling tools using this kind of devices for extraction samples of extraction analysis. The first one is a development of a sampling system for in-situ extraction of phenolic compounds in samples in wastewater. You can see here, we developed this functionalized device with a MOF. I would like to check. We can take the device and put in the station, okay? Like that, we don't need to take the sample to the laboratory, 2 liters, 5 liters, just we take the device and we put in the plant of treatment. Like that, we take that and we go to the laboratory to make the extraction and then the analysis by HPLC, for example. And like that, we can determine different compounds. But the other example is, for example, utilize the same principle, but we need, in this case, we use for that an automatic system. That means we put, or we take this device and we put an on-flow elution system who is coupled in the HPLC. Okay, that is another option. And then we have, for example, I would like to show you as well the different application, 2 application more for portable instrument with 3D printer, like this kind of instrument where we can make the analysis in field, inside. We now, here, we use the portable smartphone, and we can use open source data processing. The last one, we can use the same light box, and we can use as well the paper for sensor papers, okay, for determine ammonium, for example, or sulfide in biodigesters. Well, in conclusion, we can develop analytical portable tools. Its analytical tools allow to use the 3D printer and advanced material and in situ on the laboratory or using the online flow system. We can as well use the portable platform combining solid extraction and using a smartphone, for example, for fluorescence detection in determination of in situ pollutants. And we can use as well the paper sensor, for example, device to determine different kind of inhibitors of biochemical processes. And using as well, for example, colorimeter, like a colorimeter or smartphones. So in general conclusion, this work demonstrates the versatility and applicability of 3D printing and advanced technology for the monitoring of pollutants in wastewater treatment plants. Thank you.